Assalamu alaikum everyone. Hope you all are fine. And now we are starting our topic of electromagnetic waves. We have studied about light waves. We have studied about mechanical waves which need material medium to travel. But there is another type which can travel through vacuum. Like mechanical waves, since they need material medium, they cannot travel through vacuum like surface water waves, sound waves, they all are mechanical waves. Waves in the slinky, waves in the rope, uh, like the waves which are generated in the ropes are transverse waves because the particles of the medium vibrate perpendicular to the direction of propagation of the wave. Whereas sound waves are longitudinal and waves in the slinky are also either longitudinal or transverse. Okay, so in longitudinal waves, particles of the medium vibrate parallel to the direction of propagation of the waves. So electromagnetic waves actually they are transverse in nature. Means, but here material medium is not needed. So what vibrates? Here the direction of propagation and the electric and magnetic field, because electromagnetic, okay, it means there are two fields, electric and magnetic fields, which oscillate, okay, and they are perpendicular to each other and they are perpendicular to the direction of propagation of the waves. So electromagnetic waves they can travel through vacuum, like we receive light from the sun, ultraviolet rays coming from the sun to earth, infrared. So they all are electromagnetic and they cross the big region of space where there is no material medium present. So all electromagnetic waves they can travel through vacuum at a speed of 3 into 10 raised to the power 8 meter per second. Let us study in more detail. And before going in detail, this is the specification. In electromagnetic wave, we will study the types, basic characteristics, like they are transverse in nature and their speed. Okay, and like then there are further types like radio waves, UV, visible light, infrared, all the types, and they are divided into these types depending on their frequency and wavelength. So we will study their uses as well. Okay, uses of X-rays, use of UV rays, uses of infrared, etc. So electromagnetic spectrum is a continuous spectrum of waves which includes the visible spectrum. So see here, starting from the shortest wavelength, gamma rays, which are radioactive, then X-rays, the wavelength is becoming longer when we go towards the right side here, ultraviolet coming from the sun and some lamps, they emit ultraviolet rays, visible light which is detected by human eye and animal's eye, okay, then infrared which is responsible for heating, microwaves and radio waves. So these are the categories of electromagnetic waves. Here the radio waves, the longest wavelength means lowest frequency, gamma rays shortest wavelength and highest frequency. So it is divided into 7 bands, which in order of decreasing wavelength are radio waves, longest wavelength. So when we go further, the wavelength will decrease. Microwaves, infrared, visible light, ultraviolet, X-rays, and then gamma rays. Out of all these, only gamma rays are emitted from the nucleus of an atom. Okay, so they are nuclear radiations. X-rays due to the transition of electrons from one shell to other shell. Okay, but that has to be inertial transition. Ultraviolet rays also due to the transition of electrons, but not it's not necessary that they are inner electrons, okay, and the electrons in the inner shell. No, depending on the energy level difference, so that is not needed at all at this stage. Visible light also because of the movement of electron from one shell to other shell, right? So radio and microwaves they are generated in different ways. The methods are different. So longest and the shortest. So gamma rays shortest and radio waves have longest wavelength. So listing in order of decreasing frequency and energy, let's have a look at it. So now if we study in the order of decreasing frequency, so gamma rays, since they have longest shortest wavelength, so it means they have highest frequency. Okay, then we have X-rays, ultraviolet, visible, infrared, microwaves, and radio waves. So highest frequency to lowest frequency, and the one which has more frequency carries more energy. So it means the greatest energy is possessed by gamma rays and the least energy radio waves because they have lowest frequency. There are some common properties. Of course, they are different from each other. Their frequencies are different. Their wavelengths are different. Okay, but they have some properties in common, like all the electromagnetic waves. They all transfer energy. They all are transfers in nature. But here, the particle of medium does not vibrate. It is electric and magnetic field which vibrates, and they all travel at the same speed through a vacuum, that is 3 into 10 to the power 8 meter per second. This is the speed of all the electromagnetic radiations, that is from radio waves till gamma rays. And in another medium like water and any other medium, that depends, some may not enter, and some, if they enter, their speed will be affected, like light. When light enters glass or water, its speed decreases. Okay, so they all undergo the phenomena of reflection, refraction, and diffraction. Okay, so they will be reflecting, obeying laws of reflection. They will refract also, means their speed will change when they enter from one medium to another medium. Okay, so this is a comparison, conversion of millimeter per second into miles per second. So air, light actually almost has the same speed in air. It's very like it's not affected much, but in glass the speed will decrease. In water also the speed will decrease. Okay, but nothing can be faster than the speed of light. That is according to Einstein's theory. So the fastest thing in the nature is the light which travels through vacuum, and all electromagnetic waves travel at that speed in vacuum. Let's have some questions. Let's solve them. Calculate the wavelength of a radio wave in a frequency 100 megahertz, and its speed is this much. Okay, so you remember using the formula V is equal to F lambda, that relationship. So this will be used here. Lambda wavelength measured in meter, frequency measured in hertz, and speed measured in meter per second. So we have to calculate the wavelength. So it means lambda has to be made subject. So lambda is equal to V divided by F. So we get this 3 into 10 to the power 8 meter per second divided by 100 megahertz. So mega means 10 to the power 6. So this is 3 into 10 to the power 8 and divided by 100 into 10 to the power 6, means 1 into 10 to the power 8, you can say. So the answer is 3 meters. So this is the wavelength of radio waves, and that is the wavelength in air. Another question: calculate the frequency of light waves of wavelength that is 0.0007 millimeter, and the speed is the same, that is 3 into 10 to the power 8 meter per second. So we have to calculate the frequency. So same relationship is used here. V is equal to F lambda, and now F has to be made subject. So F is equal to V over lambda. So 3 into 10 to the power 8 divided by 0.0007 millimeter. Again here millimeter is to be converted into meters, means into 10 to the power minus 3. Milli means 10 to the power minus 3. So it means there will be it will become even smaller quantity, like there will be more zeros added. 3 into 10 to the power minus, like 0.007 into 10 to the power minus 3 will cause this to become 0.000. They were already there, and 3 zeros are added due to 10 to the power minus 3. Now if we divide this, the answer is this much. Okay, so this is the speed of light. This is light wave, and this is in air. Because how do we know that this is in air? Because the speed is 3 into 10 to the power 8 meter per second. 4.9 into 10 to the power 14 hertz. If you write it in the scientific notation, this is the answer. Okay, so all the colors of light, they have the same the order of the frequency is 10 to the power 14 for all the colors. We know that light consists of 7 colors, which we studied in the chapter dispersion of light. When light enters the prism, it disperses into 7 component colors. So red, starting from red, which deviates the least, and the violet, which deviates the most. So these 7 colors, for all of them, the frequencies, the order of the frequency will be of 10 to the power 14. These numbers will be different. 4.29, it is for, this is an average frequency it's given. If we talk about the particular color like red and violet, the, of course, frequency will be different, slightly varies. Red has the lowest frequency and violet has the greatest frequency. So here, this is a small exercise. We have to fill up here gamma, and what comes in these blanks. This is the longest wavelength. This is the order of highest frequency. This other one is the order of longest, starting from longest to shortest, and then greatest energy to lowest energy. Let's solve it. The answer. Okay. So highest frequency gamma, lowest frequency radio waves. Now we start from the longest wavelength. What will come? Of course, the radio waves. Okay, that will be, order will be reversed here. So gamma, shortest wavelength, highest frequency. Now greatest energy depends upon the frequency. So gamma, maximum energy. And radio have lowest energy. Now some blanks to fill in. The electromagnetic dash is a group of waves that are divided into how many bands? Let us fill up. Spectrum is a group of waves that are divided into 7 bands. Gamma rays have the shortest wavelength, highest frequency, and energy. The rest of the spectrum in order of increasing wavelength are, when we talk about this, after gamma rays we have X rays, and the wavelength increases when we go towards this right side. Ultraviolet, visible, infrared, microwave, and radio waves. All electromagnetic waves travel at the speed, same speed, that is in vacuum. Okay, in other medium, I just told earlier, it will be different. Now we will study about these electromagnetic radiations in detail. We will study about their uses and how they are produced. Okay, so these radio and televisions, this communication waves, because they are used for the communication. So radio and television, they make use of radio waves. Radio waves have the longest wavelength of the electromagnetic spectrum and also of the order of 100 meters. Okay, so this is the transmitter. It's an antenna, okay, which will produce radio waves. Radio waves are produced by oscillating electrons. The electron which accelerates. Okay, so in the antenna, the accelerating electron will generate radio waves, which will travel towards all the direction here. Okay. So we'll study the uses are used in radio and television communication, medicine with MRI scanner. Okay, they are like medical uses, MRI, magnetic resonance imaging, to find out the problems which are hidden inside, like for the brain tumor or inside heart, whatever the problem, they can be diagnosed, they can be detected using MRI. So MRI makes use of radio waves. Astronomy also makes use of, to study about the galaxy, we use radio waves. So this is the antenna transmitter which will generate radio waves in all the direction. These waves will travel and they will be detected. So this is a receiver. This is also an antenna. Okay, and each antenna receives particular wavelength. Not because the radio waves have range. Okay, this is not only one fixed wavelength. There will be a range for the radio waves. Okay, range of wavelengths. So any receiver will accept only particular one for which it is tuned. Okay, so when so how they are produced, I just told, by oscillating and accelerating electrons. So alternating voltage is connected to the aerial, so that will have electrons accelerating through that aerial, and radio waves will be emitted. And these radio waves, they will pass across a receiver aerial. This is also area antenna. This is a transmitting antenna, and this one is receiving antenna. So this will receive those radio waves, and that will be connected to any television inside, radio inside. Okay, so the information will be carried to that radio or television. So radio waves and ionosphere. Ionosphere is a layer of gas in the upper atmosphere. Okay, and radio waves reflect from there. Okay, this is the station on the earth. This station sends the radio waves which go towards the sky and reflect from the ionosphere, come back to the earth. They'll go again. Okay, they undergo several reflection, and they will be received at the other station on the earth after reflection. And this may be direct also, like this one, blue one is striking this way. So that depends upon the angles, and laws of reflection are obeyed. So this is received here. Okay, so radio waves, the frequency is less than 30 megahertz here. Radio waves can be reflected off the bottom of the ionosphere, enabling them to travel great distance. So that is why, like there are two stations on two different parts of the earth. Okay, so this is the transmitting one, which is sending information, and it is received at the other station after getting reflected from the ionosphere. This may have only one reflection, that is shown by blue color, or it may undergo several reflections from the ionosphere, as is shown by red one. So, so ionosphere layer is changed during the different seasons. Like in summer, it is stronger compared to the winter. So, distance traveled by, it means the during the summer, because this is stronger. The ionosphere is stronger in summer than winter. So distant radio stations can be received better in summer. Okay, so not in winter. So it means very much weather dependent. Before the advent of satellites, using the ionosphere was one of the main ways of communicating around the world. Now we have satellites, so this way is reduced. Okay, there are several other reasons also, but still this is being used for land to land communication. Okay, so that land to land communication depends on the reflection of radio waves from the ionosphere. But now the satellites are also there, and they make use of microwaves actually. So there are two uses. This is microwave oven and texting, mobile texting. You can send messages using your mobile, and this will go to the satellite. Radio waves, they are not used for this purpose, because they have longer wavelength compared to microwaves, and they will lose their energy when they will go to the sky, go up to the higher altitude, that is towards the satellite, which is revolving around the earth. Satellite is an object which revolves around the planet, so that revolves around the earth. And when we use radio waves, then they will lose very much large amount of energy before they are received at the satellite. And when the satellites will increase their amplitude and they will send it back to the earth, again they will lose the energy. So microwaves are preferred for this purpose. So this is the wavelength, 10 centimeter, of the order of 10 centimeter microwave. These are their transmitting antenna and receiving antenna are different. Okay, you might have seen your this picture, like on the top of the buildings, on the top of the houses. These are the stations, you can call them. okay, which will be sending and receiving the microwaves from the satellite, sending towards the satellite and receiving from the satellite. Used for cooking, of course, you have microwaves oven at home, so they are used for cooking and mobile phone communication, satellite television, astronomy, finding out about the origin of the earth, so how the earth was originated, what was the origin that we now know that that was the big bang theory. So that is also a result of that microwaves. So again, microwaves, they have dangers because they produce heating in the body. Okay, our tissues are heated up, and see the microwave oven, they contain metal shielding to prevent the microwaves from leaking out, because if they leak from the sides, from the gaps of the door, then of course they will be dangerous for us, because when they will be penetrated into the skin and they will produce heating. So excess use of any like these radiations is dangerous for a human body or for animals as well. So too much use of mobile phone also, it may lead to brain damage, because they, my mobile phone also make use of microwaves. So that is why at night you should, especially while sleeping, you should keep your mobile phones shut down, okay, so that these radiations, they do not cause any harm. Now infrared radiations, they are also heat radiations. All hot objects emit and absorb infrared radiations. Okay, the hotter the object is, the shorter will be the wavelength of that infrared radiations. So this is like your infrared radiation, the heater which emits infrared radiations, and they again are used for cooking, and they are also used for relieving the pain, muscle pain from the muscles, tension, etc., and treatment of like autoimmune disorders in the body. And in the same way, any like other disease like wound healing disorders also can be treated using infrared radiations. Thermal imaging. Okay, so this is the thermal image. So red means hot, because different parts of the body will absorb heat radiations differently. So they emit also heat radiations differently. So this is the red region, shows the temperature of that part of the body is higher. Blue means colder. So this kind of picture is called infrared imaging. There are some more uses. Their wavelength is about 1 micrometer, shorter than microwaves. Okay, they are emitted by all hot objects. Hotter the object is, the more infrared radiation is emitted. Means the wavelength of that infrared radiation will be shorter if the temperature is higher. Okay, so this is infrared photography. Brighter means hotter. And all objects emit infrared energy known as a heat signature. An infrared camera, and we also call it thermal imager. Okay, it detects and measure the infrared energy of the object. The resulting matrix of the color is sent to the memory of that computer, and that computer also has that, like, so it has CPU, you can say, microprocessor inside. Okay, so you can get the picture on the basis of that thermal image, the dot matrix image, that is depending on how much energy was released by different part of the body. There are some more uses. The cooking, for cooking, that's very common, and you all know it. Remote control also, like you turn on your radio, your television, turn off it using infrared radiations. Okay, so when you press the button of your remote control, infrared radiation will be, of course, will go directly towards your television, the parts inside the television. It will, of course, understand this radio, like coding and encoding. Okay, coding and decoding phenomena will go on here. Okay, this like which channel is to be chosen, and like how can you increase the volume and all that. So that components inside the television, will uh, first encode this, okay, and they will respond accordingly, like increasing the volume or changing the channel, and then that will be, this information will be decoded. Okay, communication system also you can use it like in optical fibers. Optical fibers make use of laser. They can make use of infrared, visible light also. Okay, and intruder alarm, burglar alarm also, to open the doors, automatic doors in the shopping malls, in the hospitals. Okay, they are infrared detectors which will operate a motor which will open the door when person enters. Okay, when person blocks the way of infrared radiations, the doors will automatically open. And night vision cameras also make use of it. Okay, astronomy also, to see behind the gas clouds. Now again we have some blanks to fill up. Infrared radiation has, let us choose it from there, emitted lowest galaxy cooking temperature longer centimeters. So here what will come here in this, infrared radiation has a wavelength longer or shorter, longer of course than the visible light. Okay, and is emitted by all objects. Okay, depending on their temperature, the wavelength will vary. The higher the temperature of the object, the greater is the amount of IR radiation emitted out by that body. So wavelength is a few centimeters and are used for cooking and communication. Radio waves have the longest wavelength, but the frequency of the electromagnetic spectrum, what comes here, lowest frequency. And study about the center of our galaxy. Visible light. See, you can see the number of colors which are component colors of the visible light. Your light has 7 colors. If you Vibgyor, you know it: violet, indigo, blue, green, yellow, orange, red. Okay, so this is light, and light has these colors. So you can remember any order, order of increasing frequency going from red to violet, and order of decreasing frequency when we go from violet to red. Okay, so it is emitted from again hot objects like sun and some lamps. Okay, the wavelength ranges from 4 into 10 to the power minus 7 meter to 7 to the power minus 7 meters. So this is the longest wavelength red has amongst all these 7 colors, and violet has the shortest wavelength. Okay, so this is the phenomena of dispersion. You can separate this white color. White light is separated. It is dispersed into 7 component color. Red, owing to have lowest frequency, deviates the least, and violet, since it has highest frequency, deviates the most. And this rainbow which you see on the sky is also due to the dispersion of light from the water droplets in the atmosphere. So there are uses. Of course, the main very common use is for sight in photography, optical fibers, photosynthesis, the now ultraviolet. Okay, so this is again one use shown here. Under ultraviolet is security marking show up under ultraviolet light. Okay, ultraviolet emitted by the sun and some lamps. Okay, this fluorescent lamp, they also emit ultraviolet light. This is ultraviolet radiation, and it has the wavelength, of course, shorter than visible light. It means 10 millionth of a meter. So it is produced from a very hot object like sun or typical electrical tubes. So most of the sun's ultraviolet radiation is absorbed by the ozone layer. Okay, so it does not reach the earth. Of course, if it could reach the earth, it would be very dangerous for us, because we should keep ourselves safe from the excess exposure of ultraviolet radiation, which may cause damages to the skin. So that cannot pass through the glass. So it's used in fluorescent lamp, including energy efficient light bulbs, security devices, and dentistry. Okay, and this is also for sterilization of the medical pest control. Okay, and astronomy and sterilizing the medical equipments. Okay, so this is the which the lamp which attracts the insects, mosquitoes towards it. So that is also for pest control. So we should keep ourselves safe from the ultraviolet radiation. So this is used for sunbathing also. So, but too much exposure will be dangerous. Okay, because it may cause the skin cancer or the blindness. Okay, so we should keep ourselves safe from excess exposure to those radiations by wearing proper clothing. Okay, it's see, these are the ways of keeping yourself safe. Okay, now X-rays. Okay, so X-ray photography, you can see the picture of inner side of the body because they can pass through the body and they will be blocked by bones. Okay, so they give the picture of a human body, and they are also used for studying about the exploding stars, and that is also like the source says what the inertial transition, and these are the exploding of the stars which also emit X-rays, typically 1 billionth of a meter, so very short wavelength. X-ray tubes. X-ray tube is a huge setup, okay, in which accelerated electrons, when they hit the target, they will emit alpha. They will cause the emission of X-rays. Okay, electrons are made to accelerate, and they hit the metal target, and due to their collision with the metal target, will cause this X-rays to be emitted out. They are highly penetrating, and they are stopped by several centimeters of the lead and your bone also. So the one common use is X-ray photograph and airport security to know inside of the suitcase. Okay, when you get it, go to the airport, you get your this apparatus, your luggage checking, and this luggage checking reveals the items placed kept inside the box or inside any bag. And this is a medical use, and this they are used for the treatment as well. Okay, to kill the harmful tissues inside the body, cancerous tissues. They can be killed by exposure to that X-rays, but unnecessary exposure to X-rays is again dangerous. So unnecessary getting yourself X-rayed is also not good, because too much exposure will kill the, because they are ionizing radiations, they may kill the healthy cells also. So here, this is the person being tested for the disease, and the person has to be like a person has to go for this X-ray examination. Here, X-ray pass through the soft tissues like your flesh, etc., absorbed by the bones. So the picture will be what the bones can be seen, because they will be absorbed, they cannot pass through the bones. So directed onto the patient's body, other people they should keep them safe by staying away from this, and those who will operate the setup, they of course they have to wear the proper clothing so that they should remain safe from that excess exposure to that X-rays. Okay, so containing photographic film, light proof cassette will be on the other side, okay, behind the person. Okay, that will be giving the picture of the body. So they're like lungs or different parts. Chest X-ray here is shown. Okay, so when X-ray tube is switched on, X-rays they pass through the body, patient's body, leaving a shadow image, because they are absorbed by bones. So bones are here seen, because they cannot go through that. What is behind the bone is not seen, but where there are no bones, that part is, because they can pass through the soft tissues. So breakage in the bone can be examined here. Okay, when the film is developed, the parts exposed by the x-rays are darker than the other parts. Okay, so these parts where the x-rays will pass, they will be darker. Okay, and this is white, means absorbed, they are absorbed here. They cannot x-ray radiations cannot pass through these bones, so this part will remain white. Okay, lighter region on the radiograph. Now, gamma radiation's highest frequency and the shortest wavelength. Okay, nuclear explosion, due to the, they are emitted from the nucleus. Okay, so out of all these seven types, the only nuclear radiations are gamma. Okay, they have their uses and they are dangerous also. Okay, we use them for different purposes, but for the cure of the cancer and for detecting faults in the machinery, we use X-rays. And gamma rays are also emitted from the materials falling into the black hole. This is another source, but on the earth, this is due to the nuclear reaction which are carried out in the nuclear reactor. Have the shortest wavelength and 1 million millionth of a meter. Radioactive substance, those atoms which emit nuclear radiations like gamma radiations are radioactive. Very penetrating, highly penetrating. They can pass through our body, and we can also use them to detect any disease inside the body or to cure the disease also. Kill the cancerous cell. Okay, but we have to keep healthy tissues safe from the exposure of gamma radiations. Okay, we have to allow these gamma radiations enter those parts only which are cancerous and which are to be treated. Other healthy tissues should remain protected from the exposure of these gamma radiations. Okay, and they are also used to kill harmful bacteria in the food. We can use ultraviolet also for this purpose. And sterilizing surgical instrument, we use gamma, but because gamma are nuclear radiation, so ultraviolet can also be used for this purpose. Too much exposure to gamma radiation is dangerous. Okay, so high doses kill living cells. So that's why I told you in the previous slide, that is when we use it for curing cancerous cells, cancerous tissues, the healthy tissues should not be exposed to these harming these radiations. Okay, because they may cause gene mutation. Okay, they may cause also wild growth of the cell may grow wildly, that is, it may become cancerous, because wild growth, unwanted growth is also cancer. So that may be caused by unnecessary exposure to gamma radiation. Even x-rays also may cause this thing. So how can they like people keep them safe? So they have to get the medical checkup regularly. Those who operate X-rays in the hospital, or those who operate they work in the radiographic department, radiology department. They have to get regular checkup. Okay, and they should wear the badge that which will show to which radiation they are exposed to. Okay, so that amount of damage can also be calculated. So amount of damage which is caused by these radiations depend upon how much was the radiation, what quantity of radiation was there, what intensity was there, and for how long the person was exposed. So all these factors, they will be affecting the amount of dose which is absorbed by person. Okay, so there is a calculation, there are some calculations like which up to what quantity, if it is absorbed in the human body, person will not be affected, and crossing that limit there are values of these exposure to the radiations, that is beyond this certain value the person may have certain disease, maybe like cancer, etc. So gamma and X-rays are, of course, what will come here? Most dangerous radiations of the electromagnetic spectrum, because they may cause ionization of the cell. Okay, they may cause gene mutation, they may kill healthy cells, etc. Okay, cell and cancerous growth also, and can be, but they can be used for the treatment also. Okay, so both require several centimeters of lead to be stopped. Okay, they can pass through aluminium, they can pass through paper, etc. So if lead sheet will block them. So X-rays are absorbed by bones, and we, because of this characteristic of X-rays, we get the radiographs, the picture of the chest X-ray you just saw in the previous slides. And gamma rays are used for killing the cancerous cells, as well as to kill the bacteria which are in the food, and sterilization of medical instruments. Now there are some questions to solve. So that's all, and watch the video carefully, and any queries ask me in the class. Allah Hafiz.